everyone, it's Larson in the lab, and today we're going to be looking at a stoichiometry lab. Today we're going to be beginning a 3-day long lab where at first we are going to have two materials that we are going to combine. Those materials we're going to combine for a reaction are called the reactants, and we are going to combine them today. And then tomorrow we're going to filter them, and then on the third day we are going to figure out the mass of our products. So this reaction does involve two reactants. One is potassium iodide, which is solid. It's in powdered form here. The other is lead nitrate. So lead nitrate is also a powder, and you can't just combine those two powders and have them react. So what we did earlier, me and Miss Cook, is we made a lead nitrate solution. We dissolved lead nitrate into some water and made a solution out of it so that the reaction could then take place in that liquid solution. So two reactants, potassium iodide and lead nitrate, are going to come together and do a reaction, and we're going to be able to predict which products will be made and also how much of the products will be made based on the materials that we have used. So we want to think about, when you have a reaction between lead nitrate and potassium iodide, what kind of reaction is that? What reaction is taking place? Which category of reaction is it? Is it a double replacement, single replacement, decomposition, synthesis? What kind of reaction is that? We're going to figure out if it makes a precipitate or not. And if it does make a precipitate, what is the precipitate that was made? We're going to find out if one of these was a limiting reactant, was either the lead nitrate or the potassium iodide a limiting reactant in this particular reaction, and what was the one that was in excess. Once we figure that out, we can predict how much of our precipitate might form, and we can measure the actual precipitate that formed and do a percent yield problem to find out how good of a job did we do with this lab. Was our actual mass that was produced close to the predicted mass that we would produce just based on our stoichiometry in the lab. So today I am wearing goggles because I am working with chemicals and I would not want something to happen to my eyes. But what I'm also going to do to be sure to be careful is to wash my hands at the end of this lab. Now, what I have measured out here already, because we already made this lead nitrate solution, and what I did is I went ahead and measured out 40 milliliters of that lead nitrate solution. And I'm going to take my 40 milliliters of my lead nitrate solution and I'm going to put it in this beaker. This beaker is where my reaction will occur. I'm going to set aside my stock solution and these materials that I'm not using anymore. Again, that was my lead nitrate. Next, what I'm going to do is I'm going to add some potassium iodide. And I'm going to add somewhere between 2 and 2.5 grams of my potassium iodide. So how will I do that? Well, I have an electronic balance here, and what I need to do is actually to not have this electronic balance at 0 right now, but to put my weigh dish on the balance and then 0 it. That way, when I'm doing my overall calculation of mass, I'm not including the mass of the weigh dish when I'm figuring out the mass of my potassium iodide. So now I have the weigh dish on my electronic balance and I've zeroed it, so it looks like 0 grams. Now I want to get between 2 and 2.5 grams of my potassium iodide. And this is a powder, like I said before. It's a little bit older, so it's a little clumpy, but I'm going for the loose powder. All right, right now I have 0.41 grams. That's not enough. Now I have 1.31 grams. That's not enough. All right. Now we have 2.28 grams of potassium iodide. And what I'm going to do is I'm going to write that information down so that I can keep track of what mass of potassium iodide I started with. So I'm writing down here 2.28 grams potassium iodide. Okay. So I want to add these potassium iodide and my lead nitrate solution to the beaker that I had. I would not want to have added that to a graduated cylinder because it might have gotten stuck and not come out. So I do need to make sure I'm already going to add it to the beaker where my reaction will take place so that all of it can go into the beaker. So what I'm doing is I'm going to take this potassium iodide and add it to my lead nitrate solution. Ooh, it's yellow. The next thing I need to do is to stir this with a glass stirring rod because it's not very well mixed right now. So I'm going to stir this for about 30 seconds. And I'm using the camera timer to calculate 30 seconds. So after I'm done stirring this with a glass stirring rod for about 30 seconds, and the reason I'm stirring it is to allow these molecules to come into contact with each other, to react with each other more readily. So I'm stirring this, and what I'm going to then do is I'm going to push this beaker over to the side, and I'm going to clean off my stirring rod and also my materials that I've used previously in this lab. I'm going to clean them off, and I'm going to wash my hands because I've been working with chemicals. But I'm going to set this off to the side for about 24 hours. And after about 24 hours, I will come back to this and we will do the next part of our procedure, which does involve filtration. So tune back in or check out the next video to see that. Thank you so much for listening.